Hello, I'd like to welcome you to our digital classroom brought to you by HD Supply. I'm Jerry Winslet, along with Jason Leonard.
Hey, everybody.
How you doing today, Jason?
Doing good, Jerry. Doing good.
Today what we're going to be talking about is standard electric top service calls. But before we begin, I just got a few things I want to say. If you have any questions about anything we're going to cover here today, just go ahead and use the chat feature, which is on the right-hand side of your screen. Just go ahead and type those questions in there. We'll get to them as they come. If there's a lot of questions, we'll get to you as fast as we can. But also, there is a downloadable PDF about what we're covering today. So it's going to cover a couple of, there's a couple of them there. There's one for not enough hot water, and there's another one there for no hot water. So go ahead and download those PDFs, and you can kind of follow along as we go through this training today. So we've got a lot to cover, so let's go ahead and get busy.
Yeah.
So we're going to talk about the top service items. You know, we've got call centers here, so we kind of know what's going on in the field when it comes to electric water heaters, and it's pretty good that we're doing this now here, getting close to the holidays. But you know, we're talking about electric water heaters and what they might experience on new installations, on water heaters that have been in there for a while. And really what we're going to do today is just kind of give them tips that's going to kind of help them out in the field, especially like those PDFs that they can put in their toolbox and carry with them to a job site.
Yeah.
Especially because, you know, they may not be working on water heaters all the time. So, you know, it's kind of hard to remember some of this stuff. So this is going to be a really good tool for them.
Yeah, I mean, that's really the key to these PDFs. Of course, you know, our friends down at HD Supply, they got you hooked up with all the physical tools that you need. But we kind of look at these PDFs as a tool as well, right?
Exactly.
It's a tool that you can take back, stick in the toolbox, and when you need it, you got it, right? What determines whether the tool is good or not, it doesn't do what I need it to do, right?
Exactly.
Does it serve a purpose? And that's what this PDF does. You guys are busy, right? You're getting a lot of calls. So when you get that call on the electric water heater, your whole goal, get in there, get that customer back to hot water as quickly as possible, because we got to get back on to the next job,
Yeah,
right?
we want to do this very fast and quick and get them in and out of there.
So that's what this PDF really does for you, is give you a step-by-step procedure on how to go to the problem as quickly as possible, fix it, and get out of there.
All right, before we begin also, really on the troubleshooting side of it, we do, speaking of tools, we really have to have the right tools.
Yeah.
When we're dealing with electric water heaters or water heaters in general, gas and electric, we need a certain kind of tools for the job. So let's talk about the tools for this job, and you've got one of them right there, that multimeter.
Yeah, this is a digital multimeter, and as you pointed out, having the right tool is the key to everything,
Yes.
right? Can you fix it with a butter knife? Maybe, but it's not going to be quick. It's not going to be easy, right?
No.
Having the right tools is the key to everything. This is a Klein Tools digital multimeter. This happens to be a clamp-on type. You don't necessarily have to have the clamp-on type, but I can tell you if you do this with any type of frequency, you'll love this because it really helps you out. We'll talk about some of the functionality behind this later and how you're actually going to use it to do some of these tests.
Right.
But this is a great tool to have.
All right. All right, so, and of course, various hand tools. We've got our bag there that actually has an assortment of tools. But really, we're going to be focused on that, and maybe, you know, if we do have to change out any elements, an element wrench is very handy as well.
Yeah, basic screwdrivers, the element wrench, a digital multimeter, and you can pretty much fix anything that's going to come up on an electric water heater, troubleshooting-wise.
Right, so you need to keep those in your tool bag whenever you go to the job site and work on these water heaters, along with the PDF. So we're going to go ahead and get into this now. Now, the first call we're going to talk about, it's a top service call, is the most, the one that happens the most often, and it is a no hot water call.
Yeah, there's only a couple of calls that you're going to get with an electric water heater, right? As far as the customer's version of what's wrong, either they don't have any hot water or they don't have enough. It's one of the two.
Right.
And really, the first thing we have to do is figure out that. What exactly do they mean? When they present their problem, they're going to explain that from a standpoint that makes sense to them. So the first thing that we kind of have to do is interpret
Yeah.
their explanation of what's going on, right?
Yeah, we have to troubleshoot the call before we can even
That's right.
troubleshoot the
That's
problem. So, you know, I mean, hot water to them may not be hot water to you. So, no hot water to them. That's one of the things that we have to figure out if that's exactly what they mean, that the water heater, that means that it's cold water, no hot water, because, you know, customers' expectations. A customer may think no hot water means no water at all. I mean, it's not hot.
Yeah,
so.
we've had that.
Yeah.
You know, we had a customer that their complaint was no hot water. Well, we immediately went down all the
Oh, yeah.
troubleshooting steps to come
We
to
were
the problem.
troubleshooting.
Because that's what we do, right? That's what we do. Come to find out, they had no water coming out of the hot
Yeah.
water side of the faucet.
They had no water at all anywhere.
Yeah.
So.
So really, as you pointed out, you got to
Yeah.
troubleshoot the call before you can start troubleshooting the heater.
Yes.
What exactly do they mean, and how do we interpret their explanation of what's going on?
Yeah, so we need to verify that there is no hot water throughout the house. I mean, they could have no hot water in one area and have hot water in another, and that means that's not a water heater issue. That's more of a plumbing issue.
Exactly.
So that's the first thing. So if I get a no hot water call and I verify that I have no hot water anywhere, you know, what's the first thing I'm going to do?
Well, now the first thing we're going to need to do is we need to find power, right? What are we after? Well, we got no hot water. Well, in order to make hot water, the unit's going to have power.
Right. Gotta have
So if
electricity.
I've got no hot water, then my first assumption is, well, maybe I have a power problem. Maybe we need to figure out power. Well, when it comes to troubleshooting electrical, right, anytime you're going to do this, the first thing that you want to do is start where you should have power and work your way back till you find it. That's really the quickest way to get to the problem. So the first thing we want to do is go directly to those top two screws. You see there on the graphic, those are the two screws that we're talking about. We want to take our Klein Tools meter, and again, now we're going to set this to AC volts, right?
Okay.
That's what we're after. We're going to set our meter to AC volts. We've got the two probes here, and we're just going to go right to that upper thermostat. We can get an overhead view, kind of see what we're talking about here. And we're just going to take these two probes and go directly to the top two screws on that thermostat.
Okay.
Now, what we're looking for here is 240 volts.
All right.
Now, of course, when we say 240 volts, does that mean you're going to see exactly 240
Yeah, I need
volts?
to see. Did I need to see 240 volts exactly?
Yeah, it's not. It may be anywhere from 230 up to 245, somewhere in that neighborhood. But you should be close, right? If we're seeing, then we know we've got power to the water heater. But that's what we're looking for, 240 volts to the upper two screws.
So if I go to the water heater and I'm checking the top two screws and I don't have 240 volts, like you said, we're just going to kind of work our way backwards, aren't we?
Yeah, the next thing we want to do is now we want to go up the water heater. Go to the junction box on the top of the water heater and check our wiring connections. You see this a lot. You get out to the job and a wire just slipped out of the wire nut for whatever reason. When the water heater was originally installed, they thought they got them both inside the wire nut and good and tight, but maybe they didn't. One of them worked its way out, got loose. Or maybe someone else has been checking the water heater before you got there, or whatever the case may be. So go ahead and check that wiring connection, make sure we don't have a problem there. Now, if we determine that the wiring connection is good, all my connections good, I should be moving current. The next thing, again, check it on back. Go back to your breaker box. It's possible someone may have been in the breaker box, flipped some breakers off or something like that. So check the breaker. Hopefully it's marked, right?
Yeah.
Hopefully when you get to the panel, there's a sticker on there or somebody wrote on there and it says water heater. That's awesome. If not, what you're looking for is probably going to be a 30 amp double pole breaker.
Double pole.
Yeah, double pole breaker. It's 240 volts, so it's going to cover up two spaces.
Okay.
So it's a 30 amp double pole. Now, it's possible you may see this on a 25 amp double pole. If you do, it's okay. Don't worry about it. It's actually fine. But in most cases, because the water heaters typically wire with number 10 wire, which is good for 30 amps, most people are going to put them on a 30 amp breaker. That's usually what you're going to see. But again, check that breaker, see if it's on or off.
All right. So, so we go to the water heater, and we actually do have, power at the upper two screws. What do I do next? I mean, what's my next step once we do determine that we do have power there?
Yeah, we pull the inspection plate, we get our multimeter, we check those top two screws, and we say, wow, what do you know? I got 240 volts. Well, we know the wiring is good, we know the breaker's good, we don't have to worry about any of that. We got power to the heater. So the first thing that I want to do now is check the ECO, the energy cutoff. On the upper thermostat is what's called an ECO, or energy cutoff, that's designed to trip if the water in the tank exceeds 180 degrees. It's a
Okay.
safety device.
All right.
Meaning if we have a part failure that causes the tank to overheat, this is going to open up and shut power off to the water heater. So all we're going to do is just take our finger, push in on that ECO. Now you should hear an audible click. You'll hear it and feel it if it is tripped. When you push in, you'll just hear this click. You'll probably hear it as well. And that tells you that now it's reset.
Okay.
Okay. If it does click, as soon as you push it in, you should be heating water again now.
Yeah, now we don't want to just go up to it, push it, and it clicks, and then put the panel back on and go back to doing whatever you were doing.
Exactly. Like we said, this is a safety device,
Right.
right? So we have to assume anytime that there's a safety device activating, whether it's electric water heater, gas water heater, powder vent, doesn't make any difference. Anytime that there's a safety device that is activating, we have to assume that it's doing exactly what it's designed to do. It's trying to tell us something, right?
Right.
And in this case, it's trying to tell us that the water in the tank is getting way too hot.
Now, what are the common causes for that? I mean, what would cause it to get overly hot like
Well,
that?
there's two. There's really only two things that's going to cause that ECO to trip. The first and probably the most common is a grounded heating element.
Right.
Over time, the heating elements themselves are going to start to wear out. They get corrosion built up. You could possibly get one that is actually grounded. Now, what happens is there's always 120 volts on that element, right? There's always 120 volts there. The thermostat switch is the other leg of 120 volts, and they meet in the middle at the element, and that's what causes it to heat.
Right.
But if we take that 120 volts and ground it out to the element, right, because the inner tank is grounded, knee bone connects to the leg bone type deal, right? So if the element grounds out to the inner tank, which is grounded, we could now start to heat that element up even though the thermostat's not shutting it on and off. So you could you're only going to heat with 120, so it's going to heat really, really slow. But we can eventually get to the point to where we're reaching 180 degrees. Now, we talked about in the middle, there's only two calls, right? Well, sometimes it may present itself as the tenant says, hey, the water is just way too hot.
Yeah, that's if you catch it soon enough. I mean, yeah.
Well, if you catch it soon enough, but also it depends on how much hot water they're actually using.
Right.
If they're using a lot of hot water, then they may never get to the point where it reaches 180 and it trips the thermostat.
But it's just hotter than what it's normal.
Yeah, if they don't use very much hot water, it's just going to hit the ECO and it's going to pop it eventually. But if they're using a lot of hot water on a regular basis, it may be getting 150, 160, maybe 170 degrees before they use hot water again. So it may not be tripping. So their report may just be overly hot water, but it's the exact same scenario that's going to cause it. So the way that we're going to confirm that is we're just going to go directly to the element itself. If we can catch an overhead again. And what we're going to do, again, take our multimeter and we're going to take our probes and we're going to put one directly to the screw on the back of the element. Right, we see that right there. Now the other lead, all we're going to do is just ground it out to the tank.
So we're just going to go to the tank on the other.
Yeah, if you see on the graphic there, you can see the steel tank right behind the element, right? So we're just going to take our other probe and touch it to the steel tank, have one on the element screw. Now you want to go ahead and check both of these screws. Right. Right, check both of them for continuity. Okay. So we're going to take our meter and we're going to set it to the continuity setting. We're just looking for whether or not we have a completed circuit, right? Right. And you'll know that you're in the continuity setting because on the meter you're going to see a symbol that looks like the Wi-Fi symbol, right? If you've been on an airplane, you see the Wi-Fi symbol or a sound symbol. Most of these make a beep, make a noise once you're in that setting. So you can just touch your two leads together, and if it makes an audible sound, then you know that that's a complete circuit. That's what we're looking for. We're trying to figure out whether or not there's a complete circuit between the element and the tank.
And because of the way, and we need to talk about how the water heater works, because we're going to want to start at the lower part of the tank first, because it's doing most of the work.
It does. Because of the way the operation works, on a completely cold tank of water, the upper element's going to fire first. It's going to heat the upper third of the tank. Once it satisfies, power transfers down to the bottom, the lower element kicks in and heats up the rest of the tank, about two-thirds. Now, in normal usage, most people don't drain the water heater completely out of hot water, right? You'll take a shower, you wash dishes, those type of things. Usually the bottom element's the only one doing anything. The upper one never fires unless you run it completely cold. So your bottom's doing the majority of the work. So it's going to fail first.
Yeah, so it's the workhorse. So that's where you would start. You would go ahead and test that element at first.
Yeah.
You know, say we go ahead and replace that, and let's test it out, and it tests out good.
Yeah. Well, if it tests bad first, if we do see the bell ring, which is
Right.
what we're looking for, then you're done. You
Right.
found your problem. Now you have to do is just replace your element. Now if it doesn't, meaning we have no continuity between the element and the tank, the next thing you would think is go to my lower thermostat. Okay, maybe the thermostat is stuck. This is the lower thermostat here. Now the way this works is on the inside of this, there's a set of contacts. Okay, so when the element gets a call for heat, these contacts are going to touch, right? In a normal state, see, these contacts are open. Now once we get a call for heat and these contacts come down, you'll get a little arc, right, as those contacts touch. It's on the inside of the element. This is internal. But as they touch that little arc, over time, you do that enough times, you can weld those contacts shut. Just that little arc at the right time over enough usage can weld that contact shut, and that's probably what's happened. If we check the lower element, it's good, no problem there, then go to the thermostat. Just go ahead and replace your lower thermostat again. Probably going to be the lower. Can it be the upper? Yes, it could. But it's almost always going to be the lower, again, because it does the majority of the work.
Okay, all right. So, so that's if our ECO did trip. Let's talk about if I go to the ECO and I press the button and it didn't trip.
Well, that's a good point. Now, if we go to that ECO and we push it in and it doesn't trip, we've already determined now I have power, right? I got power up there. The thermostat doesn't click when I push it, so I know it wasn't tripped, so I should be moving power down. Now I have to go to the element itself.
Right.
Now I can assume, I know I've got power there, I know the ECO is open and letting it through. If I have no hot water whatsoever, probably my upper element. Again, because of the way that the water heater works, the upper element fires first, heats the upper third of the tank, and then it transfers. So if that upper element goes out, if it burns out, you're not going to have any hot water at all.
Right, because it can never transfer the power down. It can never satisfy the thermostat.
Exactly. So now what we want to do, again, we told you that the multimeter was important, right? Now we're going to take our multimeter, now we're going to set it to a different setting. Now we're going to set it to the ohm setting, which is your omega symbol or the upside down horseshoe symbol. And now we're going to do the same thing. We're just going to go back to the element. Now we want to remove the wires.
Okay.
Right, the two wires that come to the element, you want to remove those, basically isolate the element electrically, right? And now we want to take our leads, and this time instead of touching it to the tank, we're just going to touch them both directly to the element themselves.
Right.
Okay. If we go to the graphic, there we go. You can see that's what we're going for. We're just going to take our two probes, touch it to those two screws, and now we're going to determine what the actual resistance is. We're going to determine the ohms value.
Okay.
Now, typically 4,500 watt, 240 volt element is going to be around 12.5 ohms, 12.5 resistance. Now, it doesn't have to be exactly that. It probably won't be exactly that. Depends on temperature, other things like that. But somewhere between 5 and 25. If the reading we get falls somewhere within that area, then it's a good element. Bad element is going to go way high.
Right.
It may go completely open, right? Or your meter may say OL, or you may get an extremely high resistance. But it's not really going to fall in between. You're either going to get between 5 and 25, or you're going to get a lot. One of the two.
Now this can happen on a new installation very quickly, and it has to do with not getting the air out of the tank, right?
It definitely can. If this is a new install and we have this scenario, I can probably pretty much guarantee you that the upper element's been dry.
Right.
We've all done it. As bad as I hate to say it, I've done it. You get in a hurry, you just don't get all the air out, especially on a system that has a lot of plumbing lines. It's a big system. There's a lot of air in the system. You can bleed it off at the TMP valve. A lot of people do that. They just open up the TMP valve, and you just keep doing that until you hear no air coming out. I'm starting to get a little bit of water, so I close it off. The problem is there could still be a big slug of air in there.
Exactly.
You want to run every hot water faucet in that house until you're getting no air spurts whatsoever. Maybe 2 or 3 minutes at every faucet.
Yeah, the key is all of the hot water faucets.
All of them.
Yeah.
Now, like I said, I've done this before in the past. I even opened the hot water on the washing machine, just so I can get all the air out of that line as well, because it will happen from time to time. But you get a big slug of air around the element, this thing's going to burn in two. It's made to be totally submerged.
Oh, you got one right there.
Yeah, there's a dry fired element for you right there. See if we can get an overhead view of this thing. You can kind of see how all the coating has been melting off. We're down to bare copper now. You also see a big hole blown right in the side of it. That's where it just blew the copper out. So basically what happens is this thing just starts to glow white hot.
Right.
Because it needs the water around the element in order to disperse some of that heat. If it's just in the air, where the air heats up really fast, right? Air heats up fast, so the element overheats and basically just blows in two. And like we talked about, the upper element has to heat the upper portion of the tank before power transfers down to the bottom. So if this element was burnt out on install, you're never going to get any hot water out of it whatsoever. Again, it is common. Even the best of us do it from time to time. I hate to admit it, but it has been done. So again, you just want to make sure you get all the air out of the system. But either way, whether it was dry fired or whether it was just bad, this test is going to get you there regardless of the scenario.
Okay, all right, and that was step number 4. Now, there is one other situation that you might run into where you test the heating elements and you test the thermostats and everything tests out good. Is a leak in the hot water side. I mean, you could get a leak on the hot water side of the plumbing system, and you could have no hot water that way as well.
Yeah, it's rare, but it does happen. If you've checked everything, my elements test good, I got power, my ECO's not tripped, this is where that clamp-on comes in handy, right? We talked about this earlier. If you're checking, say, a bunch of water heaters, and you just want to make sure that everything's okay, you're doing a normal check, all you have to do is remove the inspection plate, get to the wires going to the thermostat, either the red or the black, either side, or the wire coming right out there off the element, and just clamp that on there. Set your meter to the amp setting, right, and just check the amp draw. Most of the time you're going to pull about 18.75 on a 240 volt, 4500 watt element. So if we clamp this on there and I say I'm getting about 18 amps, you're heating water.
Yeah, and that's going to be a great tool if you have to test a lot of water heaters in a short amount of time. Say you've got an apartment complex with a lot of water heaters and you're just going in there, just routine maintenance, just to make sure the water heater's working properly. You can use a clamp-on amp meter and save you a ton of time.
Absolutely, it's really quick. And again, if you see amp draw, well, amp draw is proof that work's being done, right? So if we see amp draw, then you're heating water. That water is going somewhere. So if all of your hot water faucets are producing no hot water, but I know I'm pulling amp draw at the heater, it's going somewhere. We know we're heating water because we see the amp draw. Now you would want to check for a hot water leak somewhere in the system.
All right, so that's no hot water. You can go ahead and download that PDF version of it and walk through it step by step. The next thing we're going to talk about now, there it is right there. There's no hot water. So step by step, it walks you through exactly what we were just talking about. And, you know, whenever you're doing some of these tests, you know, always safety first. Make sure the power's off before you remove the wires and things like that. Some of these you have to use the power.
Yeah, it depends on which test you're doing. If we're checking for voltage, of course, you're going to have power on. If we're checking resistance and we want to electrically isolate that element, just turn the power off, remove those wires so you don't light yourself up there.
All right. All right. So now we're going to be talking about not enough hot water. So we're going to move on to the next call. Remember, we were talking about there's really two, you know, but there's some of them are subtle, like too hot of water and things like that can cause you to have no hot water. But this is another one. It's called not enough hot water. Now, again, the first thing we have to do is to make sure that we know what that means. Is it not hot enough? Is it not enough hot water? Does it not last long enough? You know, I mean, there's customers' expectations. I mean, these water heaters, especially if they buy a brand new water heater, a customer thinks that water heater is going to give them more hot water than the older water heater, regardless of what the temperature was set for.
Yeah, anytime that we're talking about something that's subjective, right? They're basically saying, I don't have enough hot water. Well, that's totally subjective, right?
Yeah.
There's a lot of times when I say I haven't had enough to eat. My wife says, I think you have plenty, right? So what do we mean by not enough? That's the first thing we have to do. You pointed out earlier that we have to troubleshoot the call before we can troubleshoot the heater.
Right.
That's exactly right. What do they mean by not enough? Because this gets down to an expectation, right? What do I think I should be getting? And we have to measure that against what the water heater will and will not provide.
Exactly.
To make sure that there's a deficiency there. This may not be water heater related at all. So the first thing we have to do is determine what exactly will a water heater provide in terms of hot water. Well, if we look at the graphic here, we can kind of see what starts to happen inside the heater. We get a dilution happening, right? We have a dip tube inside the water heater that takes cold water to the bottom. Now, as you're using hot water, cold water is entering the bottom of the tank. So basically, we get a dilution area that is going to temper that hot water down as that cold water is coming in.
Right.
You get about a 60% usable hot water out of a water heater. Now, what do we mean by usable, right? There's another subjective term. Well, what it really means is water that is within 30 degrees of the set point.
Okay.
Right? Now, if we have a set point of 120 degrees, right, that means usable water would be anything down to 90.
Okay.
Once you get to 90 degrees, that would be considered no longer usable.
Yeah, you'll get a lot of calls at 90 degrees. They'll think it's cold.
You will get a lot of calls.
Right.
So actually, it's more extreme than that.
Right.
Right? As most people take a shower around 105 and 107. So they're going to say that they're running out of hot water long before they get to 90.
Right.
Right? But again, you're not. If you have a 50-gallon water heater, you're not going to get 50 gallons of hot water.
No, you won't. Yeah, because
no, you're going to get somewhere around 30 gallons of hot water out of the tank. Now, what does that mean in terms of usable hot water? Well, it means at 3 gallons per minute, which is an average shower head, a 50-gallon water heater is going to provide 30 gallons of usable hot water, or about a 10-minute shower.
Now, now this can change though, because you're saying where the cold water is entering and it's going to dilute with the warm water or with the hot water. It's going to change as the water temperature gets colder. So this really brings up something because we're getting close to the holidays. The temperature is getting colder. The water temperature is going to start to get colder, and all the way from now till probably close to March and April, when the water is probably the coldest.
And it just depends on where you're at in the country.
Right, exactly.
Right? If you're in a warmer climate, you may not be seeing it just yet. Where if you're up in the upper Northeast, Nebraska had snow not too long ago. I think somebody's getting it now. It's crazy. But if you're in those areas, you may have already noticed that there's a dramatic drop. But it's all about that groundwater temperature. What's the delta between what temperature is coming in and what am I trying to get to? That's going to determine how extreme that dilution rate is. Now, there's another thing that's going on. An electric water heater with a 4,500 watt element is going to recover about 21 gallons per hour.
All right.
Now, that's at a 90-degree heat rise. So if you look at the spec sheet on the water heater, it's going to give you a recovery rate of 21 gallons per hour at a 90-degree heat rise. Now, think about the summertime. Groundwater's not cold, right? You may have incoming water temperatures of 70, maybe even 80 degrees in some areas. So during the summer, that water heater may have been recovering a lot more than 21 gallons, maybe twice as much. You may have been recovering 40 gallons about an hour. So it may have only took you an hour to heat up that tank of water in the summertime. Now all of a sudden, we're back into the winter, the groundwater's a lot colder, now it's taking longer to heat that up. You're back to that 21 gallons per hour.
And not only just that, but we're going into Thanksgiving and the holidays, so you're going to start seeing more people at the house, more people are going to be using hot water. So, the chances of someone calling you saying, my water heater's running out, I'm not getting as much as I was, go up whenever we're dealing with the holiday season and things like that.
Exactly.
But some of this stuff can be just localized in one area of the house, maybe like in a shower, where again we're starting to go into talking about. I lost my train of thought there. It could be but we're talking about in the shower area. Yeah, we could lose. Golly, I lost it, buddy.
Yeah, I mean, it definitely can be localized. We talked about in the beginning troubleshooting the call.
Yes,
right?
Localized.
Where is that at? Well, where are you seeing this? Is it in every hot water faucet in the home, or is it localized to one area? It's completely possible that we may just have a shower valve that's bad.
Yes.
That's typically where you're going to get the call, right? That's the most important thing. People are taking a shower and they go, hey, I got in the shower and I had to take a cold shower. Trust me, if they take a cold shower, you're getting a phone call. That's just the way that works.
Exactly.
So if it's just in that shower, it's very possible that it could just be a mixing valve. They may just have a mixing valve that has gone bad. On the graphic there's a
on
shot
the shower
of
valve, yes.
Yeah, the shower valve, which is, you know, today's, if you go down and you buy a shower valve today, and it's what they call an anti-scald valve, that's a mixing valve. That's what's going on in there. It's just tempering that temperature down to a safe temperature.
Right.
So it's taking that hot, taking that cold, and mixing them together. Well, they fail safe. If it goes bad, it fails safe, which means all you're going to get is lukewarm water at best. So if it's localized to one general area, then typically it's going to be a shower valve problem.
Well, given how fast the water heater recovers, and I'm back on track now, I got it now. Given how fast the water heater recovers and things like that, so sizing plays a huge part in an electric water heater, because it doesn't recover as fast as a gas water heater. So we have to overcome that. And then when we get into the holidays, when we have more people over for the holidays and things like that, we start to run out of hot water faster. What do we do if, let's say, you know, we're in an apartment, someone moves out, a new family moves in, and they use more hot water than the person did before, and that water heater's just not keeping up and can't provide them enough hot water.
And that's a common occurrence, right? Say the tenants that were in there was a young couple, right? Well, they may not be using very much hot water, right? Now, they've moved out, somebody else has moved in, and it's a couple with 3 kids, right? Now, their hot water usage is going to be completely different,
higher,
right? So that plays a big factor as well. And again, we're going into that time of the season right now where you get all of the electric water heater calls.
Exactly.
Right? This is when it starts to happen. Again, groundwater temperatures are starting to change. It's the holidays, more people in the home. They do not recover as fast. So they got people staying with them, a lot more people taking showers. They notice that now I'm running out of hot water. You would think that people would make the correlation. More people in the house, I'm going to have less water.
Exactly.
I wish that was true. We have to remind them of it,
well,
right?
some people think that the hot water came with the house. You know,
that's right.
That's what happens, you know. So, but yeah, that can happen.
Yeah.
So what do we do about that?
Well, the best thing you can do, again, sizing is extremely important. And we talk about expectations, right? If we determine that there is a deficiency in what the water heater provide and what they actually want to get out of it, there are some things that we can do to kind of close the gap on that. And the best thing that you can do is add in a thermostatic mixing valve, right?
All right.
Basically, the way the thermostatic mixing valve works, it's a device that is going to take in the hot water, take in the cold water, and temper that down to a desired temperature. We see on the graphic there, you can kind of see how the two are going to meet. The mixing valve is going to temper that down. What this allows you to do is now we can store the water in the tank at a much higher temperature, say even 160 degrees. Well, what does that mean for us in terms of a shower? Well, we talked about the fact that most people will shower around 105, 107, right? Well, at 120, you're mixing in a lot of hot water. There's very little cold going into it at all to get to that magic temperature. But at 160, I'm having to mix in a lot of cold, so there's not nearly as much hot water coming out of the tank. Therefore, that shower is going to last a lot longer. Okay, so now we can turn it up without the risk of scalding. Right. The whole issue with storing, we have to store the water temperature at 120 degrees because of scald risk. But once we go into a mixing valve, and then we know that that's going to temper that down to a desired temperature, and the fact that it fails safe, now I can store the temperature, store the water in the tank at whatever temperature.
Yeah, because you're going to use less hot water. Yeah. All right. So once we've determined that that's not an expectation issue, it's not, you know, the seasonal. We've got it sized properly. It's going to be a heating element, won't it? I mean, that's really what insufficient hot water is going to be, or not enough hot water.
Yeah, if we've done everything on there, right? We've done all of our checks, we've done everything else. Everything seems to be checking good. I don't have an expectation problem. Right. That the water heater should be producing, and it just isn't.
Right.
Then typically this is going to be a lower heating element. It's almost always the cause, right?
Because it works all the time. I mean, you saw in that graphic where there was, cold water is being shot at the bottom, so that's what's going to cool off first. So that lower heating element on normal use is going to be working most of the time.
Again, in normal use, the upper one probably never fires at all. It's almost always the bottom every single time. So it's typically going to fail the quickest, right?
All right.
So again, now we're going to do the same thing that we did earlier. We just need to check the element,
Okay.
right?
So, yeah.
So we're going to take our element, we're going to take our multimeter. Again, we're going to turn power off, remove the 2 wires so we can electrically isolate the element. With our meter set to the ohms reading, again, we're looking for the actual resistance value.
Right.
And we're just going to ohm out the actual element itself.
Okay.
And again, we're looking for around 12.5 on a 4,500 watt, 240 volt element. Again, anything between 5 and 25 should be good. If you're outside of that range, then you just need to go ahead and replace the element. You probably want something like this, a good element wrench to remove that out. But
yeah,
just
it's a
go
good
ahead.
idea to have that, by the way.
Yeah, these are good. They sell the what they call the element wrench,
Right.
Which is basically an octagon-shaped piece of metal. It'll get the element out no problem. But if you're doing any of these consistently, meaning I'm going to change a lot of them, you're probably going to want to get one of these. The element wrenches, just the metal ones, they're good, but after 5 or 6 times, then they start to open up a little bit and they don't grab nearly as good. So our friends down at HC Supply can definitely take care of you on this, get you hooked up with one of these. This will last you a lifetime.
All right.
But go ahead and change your element. If we're outside of that range, then you just want to pop that element out and change it out with a new one.
Yeah, I do see on some of these graphics, we're talking about an Incaloy a heating element. Let's talk about the Incaloy. And,
yeah, there's your Incaloy element right there. If we get an overhead look, we can kind of see the difference between these two. Now, depending on which model of water heater it is, how old it is, it may have different styles of elements in it. It could be what they call low watt density or high watt density.
Okay.
This is an example of the two. This one here is a high watt density. This one here is a low watt density. And the way we know that is basically the surface area, right? We see that this one is straight and that long. This one is roughly the same length, but if we notice it comes down here and turns and goes back, it turns upon itself.
Right, yep.
That just means it has a lot more surface area. Now, they're both 4,500 watt, they're both 240 volts, they're both producing the exact same amount of heat. The difference is I'm spreading that heat over a larger surface area. That means the surface itself can be a little bit cooler.
Okay.
That means it's going to last a little bit longer. It's going to resist sediment, those type of things, a little bit better. This one also happens to be what's called an Incaloy element.
Okay.
It will last roughly 2 to 3 times longer than your standard zinc-coated copper elements.
Copper, okay.
So the Incaloy is going to last a lot longer. If I'm going to do a replacement, this is probably the one I'm going to go with. It's going to last a lot longer.
Right.
I'm going to be in there for less amounts of time. This is what's going to allow me to do planned change-outs as opposed to emergency change-outs, right? Okay. Especially when we're dealing with apartment complexes and those type of things. You want to do all your maintenance as people move out. That's the best time to do it.
Yeah.
That way I don't have people, breathing down my neck. When am I going to have hot water? All this kind of stuff. As they move in and out, you go in and do your maintenance. Now we can say, well, I can look at my records and say that the element in that water heater hasn't been changed in 5 years, 6 years, 7 years.
Right.
People are moving. I'm going to go ahead and change it now, as opposed to waiting when people are living there. They have an emergency. There's a call. I may not be able to get to them right now.
And they call you at 2 o'clock in the morning with no hot water.
Because that's when it happens, right?
Yeah,
Murphy's
of
Law.
course.
Murphy's
It never
Law.
happens when
so
you're ready.
plan change out are much better if you can do it. So by going with an element that's going to last a lot longer will allow you to do that.
All right, so really, go ahead, download those PDFs. That's covering the no hot water and then insufficient hot water or not enough hot water. Go ahead and download those. Put those in your toolbox.
Absolutely.
I don't know if we have any questions. It doesn't look like we have any questions. No?
Yeah, that's about it. Just to recap some of what
Yeah.
we're talking about, anytime you have a problem with an electric water heater, meaning no hot water or some hot water, no hot water is always going to be in the upper portion of the tank. So if you got no hot water, look at everything in the upper portion. If you have some hot water but not enough, look in the lower portion. That's the easiest way to just cut the water heater in
Yeah,
half.
I mean, that's the
You know where your
easiest way to
problems
do
are
that,
at.
looking at it. Yeah, that's good stuff. But
That's it.
if you do have questions, you can always email us at university@hotwater.com. We'll answer your questions. You know, but you know, if you have folks who missed this broadcast, a recorded version will be available in about 24 hours. You can go to our website, which you're already on right now. That's university.hotwater.com/HDS.
And if you need any of the information that we covered in today's show, a copy, a PDF version of that PowerPoint that we went through with all that information.
It
those
may be
part
on there as
numbers,
well.
is on the website. Should be somewhere right in here somewhere.
Yeah, there's
you
the
can go back to
PDFs
that.
right there. There we go.
There you go. So if
All
you
right.
need any of that information, any of the part numbers or anything, we've got that for you
Yeah,
too.
all those part numbers are on there. But I really appreciate you tuning in. Jason, thank you very much.
Thank you.
For Jason Leonard, I'm Jerry Winslet, and we'll see you next time.
Thanks, guys.